Alright, let me just make sure the focus lock is on here. Okay, whoops, there we go. Oh. Alright, focus lock is on. I'm just going to quick write up questions 1 through 4, hopefully in about 10 minutes. Ooh, time's short. Might not be able to get through all 4 right here. Determine the acceleration of the system shown below in terms of m, little m, and any fundamental constants. Alright, so there's a couple ways to do this, but I'm going to show you the first way. This is big M, little m. The whole system is going to be accelerating like this, right? Both of these are going to be accelerating to the right. Big M's got Fn, Fg, force of tension acting on it. Little m's got force of tension acting on it, and it's Fg. So I guess I should probably draw the force diagrams for each, right? All right, Fn, that going down is big Mg, and that's Ft. These vectors should be the same length. That's kind of my bad there. Force diagram for this one, we have the same Ft pulling it up, and we have little mg pulling it down, right? So mg should be bigger than Ft. This object's accelerating down. Sometimes I like to make a bold arrow to show that. This one's accelerating to the right. I like to make a little bit bigger arrow to show that. All right. So now I'm going to examine Newton's second law on each of these. So for this one, the x direction is what matters. So Ft is literally your net force, has to equal big M times A. Over on this one, now one thing I want to note here is I always make A, whatever direction A is in, the positive direction in my coordinate system, right? So for this one, all right, down is going to be the positive direction. So that means little mg, and that's going to be the y direction over on this one. Now I could do something with the y direction here. I don't really need to because I'm not factoring in friction. Over here we have mg minus the force of tension equals little ma. All right, so now I have to do the algebra. So this ft, I can put in over here, right? So I can kind of combine them and write little mg minus big Ma equals little ma. So the minus sign comes in here. This is capital Ma is the magnitude of the force of tension, the magnitude. So when I put it in here, definitely should have that negative sign, right? Because in this coordinate system, Ft is in the negative direction. That's the negative direction. This is the positive direction. So now I have to solve for A. So I bring this over here. I get little mg equals little ma plus big Ma, right? I factor the A out in front here. A equals big M, little m plus big M, little mg. And then I get A equals little mg divided by little m plus big M. Now one thing that's kind of interesting to note here is the little mg, that was the force of gravity on little m, right? This force here. This here is the total mass of the system, right? This represents the acceleration of the system. And the interesting result here is at the end of the day, like we always say, acceleration equals F over M, or F net over M. In the lab, that's what we did, right? Acceleration of the system equals the net force acting on the system divided by the mass of the system. So what you can see here is the acceleration of the system ends up being equal to the only force that isn't balanced out, right? We think of this system as being, just one big object that has a total mass of little m plus big M. Well, the tension just holds that object together. That's not an external force. The normal force on this one and the gravity on this one, they cancel each other out. The only force that's left over to do any acceleration here is the force of gravity. So it's only this little force of gravity acting on the mass that causes the acceleration of this system. So this is a little shortcut you can do sometimes, not have to do all the algebra if you just need to get the acceleration of the system, right? If you only need to find the acceleration of the system, you can often do it very quickly by just figuring out which forces aren't being unbalanced, or which forces are unbalanced. All right. So let's look at the next one. What happens when we add friction in here? Well, if you add friction on this block, then you have to add another force into the x direction over here, right? So when we look at the x direction, x of big M, we end up with force of tension minus mu mg has to equal big MA, right? Then in the y direction over here, y on little m, we still have the same thing, little mg minus ft equals little ma. So friction makes the tension have to be quite a bit bigger because the pull of the little weight is going to be going against the friction up there. So now when we put these together, right, we end up with little mg minus big MA minus mu times big MG equals MA. All right. So now we see kind of an interesting result. Bring this over here like we did before. All right. I'm just factoring that out right now, right as I'm doing it. So I get A equals the force of gravity on the little hanging mass minus the force of friction on the big mass divided by the total mass of the system. All right. Now, determine the tension in the string connecting the block. So I just have to take this now and plug it back in for the force of tension somewhere. Kind of think this one would be easier. But who knows? Oh, it's ugly any way you look at it. So I guess I'll doesn't really matter. Maybe it'll be better in this one. Man, hard to say. It's ugly any way you look at it, the force of tension in terms of the variables. So over here I'd have, well, I don't have the mu, so maybe this is the way to go. So I'm going to take the y direction in this one, plug in the acceleration, and see what we get. So mg minus ma is what ft is going to be equal to. So ft is going to equal little mg minus all of that, m times little mg minus mu mg over little m plus big M. Man, that's super ugly. I guess I can carry it out a little bit further. Mg minus, I'll distribute that, m squared g minus mu little m big M g. I guess that ends up being plus. That's still m plus m. I can factor out a little mg, right? So that ends up being little mg times 1 minus m plus mu m. Oh wait, that minus sign. Wait, I'm being sloppy here. Not good, Harmon. Okay, no, that's okay. No, but that negative sign goes with the top here. Plus negative mg, I should say. Negative m over m plus m. And we probably would finally write it as mg times 1 plus mu times capital M minus little m divided by m plus big M. All right, pretty ugly. But that's it. Well, I'm out of time here. I only got through problem 1. I'll be making another video to kind of quickly go through problems 2 and 3, or 3 and 4. All right, so take that for now, and then I'll get the other video up soon.